What is EQ? Where did it come from? What's the difference between filters and EQs? Today we're going to answer all of those questions and more. First of all, let's define what equalization is. EQ is the amplification or attenuation of ranges of frequencies. We discussed in our Frequency and Amplitude video that the human range of hearing is from 20 Hz to 20 kHz. If we just amplify a signal, we turn the whole range of the frequency spectrum up. With an EQ, you can turn just a portion of those frequencies up or down in volume. Turning a range of frequencies up is often called amplification, boosting, or just turning it up. Turning a range of frequencies down is often called attenuation, cutting, or turning it down. The concept of equalization came about as a way to fix how a signal degraded when it traveled between two separate points, like on a telephone line or on a phonograph record. The signal starts off balanced and full, but as it travels, it degrades in various spots of the frequency spectrum. When it reaches its destination, it becomes unbalanced and thin. EQ was invented as a way to amplify the parts of the frequency range that were diminished, so what was thin and unbalanced could sound full and balanced again. It was termed equalization because it was attempting to make the end result sound more equal to the initial sound. In an equalizer, there are bands and tools. A band is an area of frequencies where the tool can be applied. For example, a 4-band EQ has divided the frequency spectrum into 4 bands: low, low-mid, high-mid, and high. The tools have various ways of affecting the frequencies in the band. There are 3 tools that are commonly used in an EQ. First is the low shelf. This tool allows you to boost or cut everything lower than and equal to the frequency that you select. Let's set the frequency to 200 Hz. Notice as we boost 6 dB, everything lower than 200 Hz is boosted by 6 dB as well, creating this flat shelf that we can see here on the low end of the frequency spectrum. A similar thing happens when we cut by 6 dB. Second is the high shelf. This tool is very similar to the low shelf, except everything greater than or equal to your selected frequency will be boosted or cut. Let's set the frequency to 2 kHz. If we boost by 6 dB, everything above 2K is boosted by the same amount. And if we cut by 6 dB, the inverse happens. Third is the peak dip. This tool only boosts or cuts a range of frequencies centering on the selected frequency. Let's select 500 Hz. When we boost it by 6 dB, notice how only the selected frequency is boosted by that amount, and the neighboring frequencies gradually roll off until eventually reaching 0. It functions inversely when you cut by 6 dB. The width of the frequency range that is affected can be changed with a control called the Q, which stands for quality. A lower Q is wider, selecting a broader range of frequencies, and a higher Q is narrower. This may seem opposite to what you think it would be, but it is this way because the number is based on a ratio. The ability to adjust the Q is not found on every equalizer unit or plugin. A fully parametric EQ means that all 3 parameters are fully adjustable: Q, frequency, and gain. This is very difficult and expensive to do on an analog processor, but very common on most EQ plugins. Those are the tools of an EQ, which are not to be confused with filters. Unlike an EQ where ranges of frequencies are amplified or attenuated, a filter affects the entire frequency range and acts just like any other kind of filter in daily life, like an air filter or water filter. All filters do 2 things. They stop unwanted things from passing through while letting the desirable things through. That being the case, an EQ filter lets some of the frequency range pass through while stopping others. There are 4 types of filters. First is the high-pass filter. This filter allows frequencies above the cutoff frequency to pass through, meaning they are audible. Everything below the cutoff frequency is blocked or muted. The high-pass filter can also be commonly referred to as a low cut because it's keeping the highs and cutting the lows. Let's place a high-pass filter at 1 kHz. Notice how we only hear the tinniness and the harmonics occurring in the high frequencies, but not the lower frequencies. Second is the low-pass filter. Just like we have a high shelf and a low shelf, the low-pass filter is the inverse of the high-pass. Everything lower than the cutoff frequency will be kept while it blocks the highs. It can also be referred to as a high cut. Let's turn our high pass at 1K into a low pass. Notice how now we only hear the muddy boominess of the lower frequencies, but not the detail of the highs. Third is the bandpass filter. Think of this as a combination of the low pass and high pass that are allowing only one frequency or range of frequencies to pass through, while the surrounding frequencies get rolled off. This is similar to a peak, but the main difference is that the surrounding frequencies continue to roll off to negative infinity. Last is the notch filter. The notch filter is kind of an inverse of the bandpass, meaning that one frequency will be stopped while the rest pass through. The surrounding frequencies are slightly affected, kind of like the inverse of a bandpass. The filters have an adjustment similar to the Q in the EQ tools. This is called slope, and it adjusts the slant of the roll-off of the filter and is measured in decibels per octave. Slopes usually go in increments of 6 dB per octave, and especially in the case of synthesizers, are often called poles. So for example, a 3-pole filter would be an 18 dB per octave slope. Many EQ processors include filters as extra bands. A common layout would be a 7-band EQ, which would include 2 filters, a low pass and a high pass, a low shelf, a high shelf, and 3 peak dip bands. Many modern EQ plugins have a massive amount of flexibility, with each band being switchable between filters, shelves, and peak dips. Understanding what EQ is wonderful and all, but why does it matter if you can't apply it? Which is why you should check out this video next. Thanks for watching, make sure to like and subscribe, and we'll see you next time.